In this presentation, we look at how to draw binary search trees. So what we're going to do is draw a binary search tree for 14 nodes, 14 internal nodes. So here they are there. They are arranged in ascending order from left to right. What we have to identify is the root of the tree, and for all the subtrees we have to find the root of those subtrees. So the formula we're going to use is this one here. L is for lower, the lower of the two numbers, and U is for upper, which is the higher of the two numbers. What we have to do is find the average of those two numbers. Those are the highest and lowest nodes of the subtree. Find the average of those two, and then apply the floor function. So in this instance, we're actually finding the root. So first off, we have to find the root first. So this is going to be our lowest number, and this is the highest number, the upper number. And this here is the floor function. Now, so the floor function of 1 plus 14 all over 2, that is the floor of 7.5, and that's equal to 7. So the seventh node is the root of the tree overall. Okay, so we've identified the root of the tree. Now we have to identify some of the subtrees and the roots of those subtrees. But first off, let's just draw our tree to start off. So we have 7 here. This is node 7, and we have the left subtree and the right subtree. So that's just to start us off. Let's look at the roots of these subtrees, identify which node is the root of the left subtree, what node that is, and what node that is. So let's go back. So this is these nodes here. These nodes here are the left subtree. These nodes here are the right subtree. Okay. So what we have to do is identify the roots of these two subtrees. So first off, I'll do the first one in red. 1, the floor of 1 plus 6 all over 2 is the floor of 7 over 2 is 3.5, and that is equal to 3. So this here is the root of that subtree. Let's do the other one. 8 plus 14 all over 2. That is simply 22 over 2. That's the floor of 11. That's the floor function there. And that's simply 11. Okay, so this node here is the root of that subtree. So let's go back to our graph here. So this is the node 3, and this is node 11. I'll put them all in red. There we are. Now, moving on, we have to find the roots of the subtrees of those subtrees. This one we'll do the left-hand side first. So this subtree in particular is what we're interested in. So the floor of 1 plus 2 all over 2 is simply 1. So this here, node 1, is the root of that subtree. This 4 plus 5, or 4 plus 6 over 2, that means that 5 is the root of that subtree. It's 10 over 2, and that's 5. 8 plus 10, root of the floor of that is 9, and the floor of 12 plus 14 over 2, that's simply 13. So, and actually in most cases it's the middle value. I think that's pretty identifiable once you get the hang of it. It's only when we have two numbers in the subtree, two nodes in the subtree, is it less obvious. Okay, let's go back to our subtree. So our tree, diagram. And here we have there again. So I'm going to draw the whole thing now. So we have that subtree, that's going to be 1. And just recall that the node 2 has to be on to the right hand side of that, so to keep the order. So we have the other node here as well, the other subtree, and that is 4. And that's 5. Start again. That's 5. Put that in red. That's 5 there, and the nodes at the bottom are 4 and 6. And on the right hand side, we do something very similar here. We have 2 subtrees from node 11. I'm going to sort of squash it all in together here. And we have 11 there. This was 9, and the root of the next subtree is 13. We have 12 there. We have 14 there. We have 8 there, and we have 10 there. So that is our subtree. Then we have little terminator nodes just after that. Well, we won't get into that now, but what those are. They're just to sort of emphasize that the search has stopped. So that is our binary search tree. That's how we draw it. Again, the important thing there is that L plus U over 2, where L is the lower node and U means the upper node of the search tree, of that subtree even. And that ends our presentation.